Okay, so we'll start with the do now problem. We're solving it by substitution. So let me take what I deem to be the easier of the two equations and work with that first. So we have x plus 4y equals negative 4. All right, I need one equation somehow to be solved for one of the two variables, whatever's easier. So in this case, I want to solve for x. So I'm going to subtract off the 4y. And I'm going to get x equals negative 4 minus 4y. So that means x is the same thing as negative 4 minus 4y. So I have my other equation, do that in purple for those keeping score at home, which is 2y minus 3x equals 26. All right, so what I get from this is that x can be replaced with the other expression. Let's see if I can make this look reasonably nice. Looks all right, I guess. It looks terrible. I'm going to do that. I'll just circle it in. All right, so I can replace the x with that expression. So we're looking at 2y minus 3 times what the x is equivalent to instead of the x itself. It's equivalent to negative 4 minus 4y. So I'm going to distribute the negative 3 and solve for y. All right, so I have a negative 3 here. I'm going to distribute it to each part of this binomial and get 2y plus 12 plus 12y equals 26. Clean it up. We have some like terms here that can be combined. So we have 14y plus 12 equals 26. Subtract the 12 and cancel if you can. I mean, that's the point anyway. So 14y equals 14. All right, so if I want to get y alone, I'm going to divide both sides by 14. And I'm going to get y equals 1. So I want to get the x that goes along with that. So I can choose any relation that compares y and x. I did the work to get x alone, so I might as well take that piece of information. So x equals negative 4 minus 4y. And I now know that y is equal to 1. All right, so we can simplify, and when we do, we get a negative 8. So we just want to state our final answer, and that would be that x and y are negative 8 and 1, respectively, meaning in that order. All right, so that's our solution. All right, so now what I want to do is try to solve some systems using elimination. The elimination method allows us to get rid of one variable so that we can just focus on the other variable. All right, so one of the first challenges would be to decide which variable you're going to get rid of. All right, so let me make a note of that. Decide which variable to get rid of or eliminate. Multiply your equations by constants to create opposites in the variable that you want to eliminate. Add your equations together. Eliminate a variable. Oop, wrong thing, sorry. Oops. And solve. Once you do all that stuff, that's the process that's particular to the elimination method. Once you do that, then the rest of the approach is very similar to substitution. All right, so what I would want to do is decide which variable do I want to get rid of. So I'm going to say, let's get rid of y in number 1. All right, so let's say get rid of y. If I'm going to do that, I need the coefficient of y in the first equation to be the opposite of the coefficient of y in the second equation. In order to do that, I could multiply my first equation by 3. All right, so that would give me a new first equation of 6x plus 3y equals 18. And my second equation would stay the way it is. X minus 3y equals negative 11. When I add my two equations together, I'll chuck a little plus sign in there. I'm going to get 7x. These two here would add to 0, so plus 0 equals 7. You don't have to write the plus 0, obviously. So it's really just the same as 7x equals 7. Divide by 7, and you get x equals 1. So now I know the x value. So now it's just a question of what is y. So I'm going to choose one of the two equations, whichever one I like better. I like the first one better. I'm not really offering much of an explanation for that. It's just I looked at the two equations. I like the first one better. I mean, if you want a justification, I could say, okay, it doesn't have a negative sign in it, or it's got even numbers, more even numbers than the second one. Whatever your personal justification is, either way. Replace the x with what we now know it is, in this case a 1. And I'll have 2 plus y equals 6. And then you can subtract off the 2. And you get y equals 4. So now I know that x and y have solutions of 1 and 4. All right, so it really is just a matter of deciding which variable you want to get rid of and then getting rid of it. Like in number 2, you can go either way. You could say I want to get rid of the x or get rid of the y. Last one we got rid of the y, so let's get rid of the x. I can do that if that 5 became a negative 10, because then they would cancel. So let's multiply the first equation by negative 2. So I'd be looking at negative 10x plus 8y equals negative 44. And then the second one we'll leave as is. Add the two equations together. We now know that this is going to go to 0. So we're looking at 7y equals, we run the numbers there, looks like negative 21. Divide out the 7, and you get y equals negative 3. I just did a quick double check on that with my calculator. All right, so then now I have y. So choose the equation you like better. I like the second one better. Numbers just feel a little bit nicer. Replace the y with what we now know it is. In this case, it's a -3. 10x plus 3 is equal to 23. Subtract 3 from both sides, you get 10x is equal to 20. Divide both sides by 10 and you get x equals 2. So we're looking at xy is the same as 2, -3. Just make sure that you put your x and y in the appropriate order, x first, then y. Now, sometimes it's not as simple as just multiplying one equation by a number to get that cancellation, that nice cancellation. Sometimes you have to aim for a number that isn't already there. So that's where you'd be looking for an LCM, right? So some number that can be divided both by the 5 and the 4, for example, or the 2 and the 3. So you could use the LCM feature on your calculator. Let's say I decide I want to get rid of the y variable. All right, so I decide I want to get rid of, make a note, get rid of. All right, I would need the LCM between 2 and 3. So I'd use my calculator if I didn't know it. All right, that's in the math menu. So I'll just make a note, for LCM, we'd want to do of 3 and 2. That's math, NUM, so right arrow to NUM, and then option 8. All right, and when you chuck that in, you get a 6 as a result. All right, so that's the number you're aiming for. So I'm going to multiply the first equation by 2 because I want this to become a 6. I want it to become the LCM. So 10x plus 6y equals 4. Now the second one, I don't want it to become a 6 because I want it to cancel. So I want this to become a -6. So I'm going to multiply by -3. So -12x minus 6y equals -30. Then I'll add my two equations together. So -2x, the y's are going to cancel, that's the whole point, is equal to -26. Divide both sides by a -2 and you get x equals 13. All right, so I have my x value. Now I need the y that goes along with it. So let me just snag one of the two equations. Neither of them look too neighborly, but the second one at least has even numbers in it, so for whatever that's worth, I'll just grab it. So 4 times whatever the x is, in this case 13. 4 times 13 is 52, plus 2y is equal to 10. Subtract the 52, you get 2y is equal to -42. Divide by 2, and you get y equal to -21. All right, so we get an answer of xy that is the same as 13, -21, barring any catastrophic algebraic mistakes. Always a good idea to check. You can pop in your numbers, whether you do it in your calculator or if you use a different method, like for example substitution, you can. It's entirely up to you. But you use some method to check it, because especially when you see numbers like this, it's kind of alarming. You say, well, clearly I did that wrong, but obviously that's not necessarily going to be true. So definitely take a look at it using another method.